Hello and welcome. My name is Benedict and I'm going to show you how you can use the new feature Photometric Stereo in MERLIC. Photometric Stereo is a technique in computer vision that helps us to obtain detailed information about the surface of objects. This is done by taking multiple images under different lighting conditions. In this method, we use several light sources, each coming from a different angle. By analyzing how the surface reflects the light, we can derive the surface normals. This allows us to reconstruct the object shape and texture. Photometric stereo is particularly effective for capturing very fine surface details. Therefore, it can be used to detect scratches, dents, or deformations, for example, in PCB or battery inspection. Let's talk about the necessary hardware setup. We need at least 3 light sources. In our case, we are using 4. 1, 2, 3, and 4. We also need a camera. And all of this has to be arranged in a way so that the light sources illuminate the field of view. We are additionally using a LIMEC controller to trigger the lights as we take images of the target object. With these images, we can then perform photometric stereo in MERLIC. We prepared here an example MV app. And at the core of this app is the new tool Reconstruct Surface with Photometric Stereo. As you can see on the right side, as always, you can find information about how to use the tool in the quick tool info. The tool requires at least 3 images of the object to be inspected as input. The images must be taken with at least 3 different light sources. In this example, as you just saw, we are using 4 images corresponding to our 4 light sources. 1, 2, 3, and 4. In addition, the spatial relations between the light sources and the camera must be known and specified. This is done with the tool input parameters slant and tilt. Slant is the angle between the optical axis of the camera and the direction of illumination. Tilt is the angle within the object plane or any plane that is parallel to it. We estimated the parameters of our setup in advance: tilt values and the slant values. It is also possible to use the tool in uncalibrated mode. This does not require specification of the tilt and slant values, but we recommend to use the calibrated mode for optimal results. We also have to set up image acquisition. We can do this using the Image Source Manager. In this example, we use an acquisition sequence to capture 4 images, with 1 light source being active in each image. Once we have specified the tilt and slant values and configured the image acquisition, we can run the MV app. We recorded images beforehand because the lighting conditions in here are not optimal for photometric stereo. As you can see, 4 images are taken, each with a different light source being active. Once the images are acquired, they are forwarded to the photometric stereo tool. Together with the tilt and slant values, the tool computes the output images. As output, we receive the albedo image, the filtered image, and the height field. The albedo image returns the albedo factor of the surface. The albedo is a characteristic of the surface and describes the ratio of reflected radiation to incident radiation. The filtered image is a vector field calculated from the gradient image. And the height field is an image in which pixel value corresponds to a relative height. As you can see, the scratch is clearly visible in the output images. You can now use these images for further image processing steps. That's it! The new feature Photometric Stereo in MERLIC. And remember, This is a concept tool. Feedback is always welcome. We are looking forward to your opinions on the tool.